So when looking at classification of matter, we have a couple different classifications that you need to be aware of. The first one is what is an element. An element, remember, is made of one type of atom. You're going to learn that elements can look in a couple different manners. Okay, so representations is you can have them stand alone. But also we're going to learn that some elements are what's called diatomic, which means that they come in twos. And then you can also have these elements based off from their phase. So if these elements are in a solid, they're going to be all very close together. Okay, when we talk about elements, these are defined as a pure substance. That means that they're one type of particle. There's no difference between each of these particles. Some characteristics that we have of elements is that elements cannot be broken down or separated by chemical means. They are pure substances. Again, this means that they contain only one type of particle. They're written with symbols that are found on the periodic table. There are actually 92 natural appearing elements. There's 118 in total. They are named after people, places, Latin names, etc. Examples of this, there's like copper, calcium, hydrogen, O2, which is a diatomic, oxygen, magnesium, copper, and fluorine, also another diatomic. So these are the ones that are going to appear in twos. So those are the ones that always come in a set. They don't come individually. The opposite of an element is a compound. Okay, and a compound means that you're made up of two or more elements and you're chemically combined. Okay, this is a big part here, is chemically combined, which means that you're bonded together. Later on in the school year, we're going to start talking about bonds, but these can be represented by two different elements bonded together. You can have three different elements bonded together. And you could even have really unlimited amounts bonded together. But the big thing here is that they're not of the same compound. That's really what we're trying to get there. Okay, they're not, or I should say these compounds aren't made of the same thing. Okay, so chemically bonded means that they can be chemically separated. So again, like I said, since they can be chemically separated, this is a big part, unlike elements. They can be considered a pure substance as long as they're made throughout with the same compound. So think of water. A glass of H2O is pure H2O. H2O is a compound between hydrogen and oxygen, but the compound or the overall mixture or entity is a pure substance. Okay, with compounds, you can have different properties than the elements that make them up. Hydrogen we know is a gas, oxygen we know is a gas, but water we know typically is not a gas. They're at a specific ratio of elements within the compound. Okay, H2O will always be 2 hydrogens to 1 oxygen. Glucose, C6H12O6, is always 6 carbons to 12 hydrogens to 6 oxygens. And we write these with formulas. We write these formulas in a couple different manners. We're really going to start getting into these a little bit later on in the year and determining, okay, what compound is made up of what. But for now, we just need to be able to simply identify them. The last part that we have is with elements and compounds is mixtures. So mixtures are actually a physical combination of two or more pure substances. We know that our two pure substances could be elements or compounds. So now that we take an element and a compound and put them together, this is where we're going to start having mixtures. So representations of mixtures can be between single elements. They can be between diatomic molecules or diatomic elements and singular elements, or between compounds and sometimes even compounds and elements. Some characteristics is that there's distinct components. This means that they retain properties. They can be physically separated, and we're going to talk about separation means later on. They have variable ratios of components, which means that they can change depending on what you take in and put out and put in. Homogeneous, okay, prefix of homo meaning evenly or the same throughout, so they're evenly spaced throughout, and heterogeneous, which is unevenly spaced throughout. So think of this as like making lemonade. When you have that perfect mixture of lemonade, you have lemonade powder distributed throughout the container. However, if you add too much, you have sugar at the bottom, which is going to then create a heterogeneous mixture. Because if you were to take a sample from anywhere in the container, it would not be the same. Examples of these types of mixtures is like cookie dough ice cream, trail mix, salt water, and like the one I just talked about with lemonade. So the key vocabulary that you have to know in order to be successful is that an atom is the smallest unit of matter. A molecule is now two or more atoms bonded chemically. You can have diatomic molecules made up of the same element, or you can have them made up of different elements. And then you can have particles, which is just a physical piece of matter. It can be an atom or a molecule. Typically, I strongly encourage students to use the word particle so that they don't confuse atom and or molecule. And then the last part is a pure substance. To be a pure substance, you have to be made of one type of a particle, whether that is the same compound throughout, same element throughout if it's diatomic, or just the same element if it's monatomic. These are vocabs that you must know in order to be successful.